Why do figures with rotational symmetry get bored? No matter which way they turn, it's always the same. So we're going to be adding some transformations onto what we've been doing with dilations. But first of all, I want to go ahead and take a look at the properties of dilations because that'll help us later with similar polygons. So I've got quadrilateral A prime B prime C prime D prime is created by dilating ABCD about the origin with scale factor K. And I'm going to compare the slopes of two segments before and after dilation. The first segment is just the slope formula. I'm just using x1, y1, and x2, y2. I'm trying to show a general case. So I'm trying to deductively prove something. All right, now I'm going to take the look at the slope of the top segment, A prime, B prime. Well, the way those coordinates were created is it's k times x1 and k times y1. Here this is k times x2, k times y2. So I just put those into the slope formula. I notice that I can factor k out of the top expression and the bottom expression. Well, those two are going to simplify to 1, which leaves me with y2 minus y1 over x2 minus x1. So I've deductively proven that the two slopes are going to be the same. Now, since I didn't have specific examples, I've proven this for all cases. It doesn't matter what the coordinates are. With a dilation, the slopes will be the same, which means that corresponding segments created from dilations about the origin are parallel. By the way, I could strike the about the origin, because remember when we did dilations about points that weren't at the origin, the only thing that changed was the location. It didn't tilt or anything, so those would also be parallel. So why do I need this parallel? Well, that's going to be handy for looking at some of the angle properties when we dilate. And I'm going to do that by extending AB so it intersects here and creates point P. Now, I'm going to look at this angle right here, DAB, and D prime PB. Well, I know they're going to be congruent because we've just established that the segments have to be parallel. And here's my transversal, and these are corresponding angles. So these two are congruent. Now I'm going to look at this top angle up here. Well, this top segment and this bottom segment are parallel. So these two are congruent because they are corresponding angles. Okay, well, if these two are congruent and the bottom two are congruent, both DAB and D prime A prime B prime have to be congruent by the transitive property. So if this is congruent to that and that's congruent to that, then the first is congruent to the last. That's a transitive property, which gives us a general rule that corresponding angles created from dilations are congruent. It actually doesn't, you could strike that about the origin. Any dilations, they will be congruent. Okay, so I'm also going to compare lengths. What are the properties of lengths? This one's a little bit of work, so bear with me. I'm going to do the distance formula for the first segment, AB, and I'm just going to leave it that way, the same way I did for slope. Now I'm going to do the distance formula for A prime, B prime. Well, the difference is there's a K in there. And this is a little tricky. I'm kind of skipping a step here. I know that there's going to be a K squared when I get that all out, and I'm factoring it out, and I have to square it. Well, I can factor this out again, and I can get a K squared, but I'm going to actually pull it out of the square root, but kind of put one on it. And the square root of K squared is K. Basically, what that shows me, this is the same as the length of AB. So the length of my side of my image is just the scale factor times the original, which we saw already, but now I've proven it. So that leads to this general property. The length of corresponding sides of the image equals the scale factor times the length of the corresponding side in the pre-image. So for further reflection, how do slopes compare before and after dilation? How do we know that the angles will be congruent after dilation? And finally, how can we find lengths of corresponding sides?